All right, welcome again. Another video on the control charts, and in this chart, we're going to talk about the C chart. The C chart, it's a chart that we use for attributes, yes or no. But however, we use it when we can have more than one defect in one item. For example, number of complaints in for a hotel, number of customer complaints per week in a hotel. So that could be more than two complaints, more than three complaints, it depends. So if we have this type of, if we could have this type of data, then we should use the C chart. So if there is more than one defect per item, then that would be the C chart. What would be the calculation for the C chart? Would be the number of defects divided by the number of samples. For the upper control limit would be the C average, which is the control line, the center line, plus or minus the 3 of the square root of the C average. let's take a look into this example. The number of weekly customer complaints are monitored at the Lodge Hotel using a C chart. Complaints have been recorded over the past 20 weeks. Develop Three Sigma control chart limit to using the following data. So we have the data. Again, this is taken from the templates that I provided on D2L. You could use it and adapt, change the template as you like. Or if you could go and Google templates on the C chart, and you will find a lot of templates online. So the first thing that you want to do, add these total together, total complaints over the 10 weeks. That would be 22 complaints. So the C bar would be 22 divided by 10. So 22 divided by 10 weeks, that 2.2. Forget about this for now. All right, now we need to find out what would be the upper control limit and the lower control limit. The upper control limit would be C average, which is this one here, 2.2, plus 3 times the square root of the C average. So to avoid confusing, I'm going to delete this one here for a second. I'm going to delete it, and we go and again apply this equation. C upper control limit would be C average plus 3, so 2.2 plus 3 times the square root of 2.2. So that would be to the power of 0.5. That would be 6.65. 6.65. For the lower control limit, we're going to do the same exact thing. So I'm going to copy this, but the difference would be changing the addition to the subtraction. So that would be minus 3. All right. Minus 3. And that would be negative. So once we see this is negative, we change it to a 0 right away. And now let's take a look into how we could create these the control chart. So I deleted everything. So this is an empty. Again, this is taken from a template. So I'm going to delete that. Right. So start with the center line. That would be 2.2. You could type it 2.2, or you could use that cell. But and then for the lower control, we know that we calculated it to be negative. So this is, we change it to a 0. And you see there's the lower control limit. This is the center line, and now we're going to do the upper control limit. The upper control limit would be equal to 6.65, and that would be add the dollar sign before and after, so we could use it again. And now for the C would be, so now we have the center line, upper control, lower control, and now we have to find the C, and the C would be the number of complaints on each week. So that's 3 on the first week. As you see, we plotted the first point here, and double click on the lower corner, and the chart has been created for you. As you see, the process is in control. Looks good. There's no worries. However, maybe you need to reduce the variation. As you see, the upper control limit is way far here, so we need to look into how we could reduce the variation for the process. Hopefully we'll reduce the number of complaints, and that will bring the upper control limit a little bit lower. All right, so that's basically what is the control chart. We did talk about the different chart, the X and R, P and C, and different attributes. I'm trying, there are a lot more charts that you could find online. I don't want to confuse you. Just keep it simple for these 4 charts, X, R, P, and C. And if you could do it, master it, that would be great. The rest of the chart could be learned on your own way, but that's all I need from you to learn about these 4 types. As you see here, I'm going to share this here. As you see, this is where you could find a lot of different charts, also in the textbook available for you if you're interested to know more. And interesting about this particular chart that I want to share with you, there is sometimes you get a different sample size for some reason, and what that's going to end up, it's going to end up with a different upper control line. See the upper control line here? It's not straight line as the one before, or as a lower control limit here. It's turned to be negative, so we turned it into 0. However, here it's not straight line because of the different sample size. As you see, this is example for a grocery store, and there is a different calculation. But whenever you have a different sample size for each sample, so here's the sample number 1, for example, you have a 120. Sample number 2, we have a 100, etc. You have to calculate the upper control limit for each one of these to calculate what would be the upper control limit. But the rest of the equation would be very similar. There's something else called U chart, and that's a very similar to the C chart, but whenever we have a different sample size, we use the U chart here as well. So there are a lot of things. There are a lot of things that you could do. You could read more, you could expand. I will provide you with another video on using Minitab. Minitab, this is one of the goals that I want to share with you, on how to use Minitab to calculate all these charts and how to create these charts. However, now one last thing before I end up this chapter is how to interpret the data, the charts itself. Now, the state of control, we have the control is within the control limits when 2/3 of the points are near the center. So most of the controls, whenever you see most of the data are near to the center line, that means the process in control. A few of the points are on or near to the center value. If there's a few of the points are on or near the center, that's also that's great. If we need it to be in the center, around the center. The points appear to float back and forth across the center line. If you see the floating back and forth around the center line, that's good. That's the process in control. The points are balanced, so in a rough equal numbers on both sides of the center line. Whenever you see that the center line is balanced, the points around the center line balanced, an almost equal number, that would be a good thing, that the process in control. There's no points beyond the control limits. That's when, again, if there's no points beyond the control limits, that's excellent. There are no patterns or trends, and there's an important to study the pattern of each one of these. So as you see in this one, you identify that there is a pattern. You look into here, and this is where you see that the process going to be down and eventually will go out of the process. So what is the pattern? Identifying the pattern, a process that is not under control or is unstable display a pattern of variation. So whenever you see a pattern, that means the process is out of control. It's out of control, and there is a variation in the process. Pattern signal the need to investigate the process and determine if assignable cause, if the special cause variation happened to be found. All right, this chart will highlight the different status of the control chart. So this is a normal behavior. The points around the center line, nothing wrong with it. Here, 1 point above the above the control limit. And what does that mean? That you need to investigate for a cause or poor performance. So that would be the things that you want to look for. Same thing below the lower control limits. That would be investigating for cause for low value. For low value, there's something happened. There's a low value happen, and you need to look into that. If there's 2 points close to the upper control limit, investigate into the poor performance as well. If there's 2 points close to the lower control limit, investigate for cause why this has happened. If there are 5 points, see this 1, 2, 3, 4, 5 points above the center line, investigate for causes of sustained poor performance. So there is a poor performance is sustained over the last five samples. If there is 5 points below the center line, investigate the cause for sustained poor performance again. The trend in either directions of 5 points, investigate for a cause of progressive change. There is something happened to this change. There is a change happened in the process. You need to investigate that. Erratic behavior, that means that there's nothing going to be, sometimes it's here, another way is here, and that would be means that there's a very difficult process that you need to investigate. And for this one type of the I see there's a pattern here and a sudden change in the level investigation for causes. So this is a sudden change similar to the trend down here for this chart, but this is a sudden change in a level, investigate for causes. With that said, I want to thank you for listening to me, and that's basically the end of the chapter control limits. I try to keep it as simple as we can. We don't want to investigate. We don't want to make it difficult. Just to keep it simple, this is the best way to understand the subject. With that said, I'd like to thank you so much for being with me. Let me know if you have any question or if you have any concern.